talk about a little bit of proportionality that happens. I mean, just waiting to see what the lip service is all about up back there. We good? All right, so the first blank says that the diagonals of a parallelogram have special properties. We talked about one of those properties yesterday. What was the thing that we said yesterday that the diagonals do? They bisect each other. Okay, so under diagonals of a parallelogram, we're going to write that the diagonals bisect each other, which does mean each piece is congruent. And then if you take a parallelogram and you draw one diagonal, you have to imagine that it looks like a bunch of different ones, but if we take our parallelogram here and we draw one of the diagonals, what two shapes did I just make? Triangles. And that makes actually two congruent triangles, okay? That's what you're going to fill in here. Okay, so each diagonal separates a parallelogram into two congruent triangles. We only drew one just so that you could clearly see the two triangles in that parallelogram. So if you remember yesterday, we talked about the angles and stuff. So this angle here would be the alternate interior angle to this one here, right? So those two would be congruent. And then this one here is going to be the alternate interior to that one here. And then what do we know about opposite angles? We said that those were also congruent. Okay, so that shows that all three angles in each one of these triangles are congruent. So that's showing you how the triangles can be congruent because of that. All right? So, I want you to solve for y and z, and I'm laughing, and I'm going to see if anybody notices it. Go ahead and solve for y and z. You have a picture of a parallelogram. You have some diagonals drawn.
No, why are you erasing it?
Because I want you to do it by yourself. I literally just did it.
You right.
Note to self, double check the notes next time so I don't give exactly the same question. All right, again, diagonals bisect each other. So take a look at one diagonal. Set its two pieces equal to each other and solve for whatever the variable is. They're what to each other?
Same.
Yeah, so what part of math means the same?
Right.
Yeah. So what do you need in here? So what I want you to do is solve for y. Then I want you to solve for z. And then the third part there is asking you to find the length of JL and MK, which means you're going to have to plug things in to find the length of the segments. So once you find y, once you find z, plug those back in to find the length of each segment. Once you plug it back in, you have to do some more. No, it's 2 times 5 plus 7. So if I'm solving for y, what two pieces are equal to each other? Set up my equation for me. Look at the diagonal that has y on it.
Are we talking what?
Yep.
Oh, 2z plus 7.
That's not as a y. Ronald, you said 3y minus 5 and what? Yeah. Okay, we're setting those two pieces equal to each other, the 3y minus 5 and the y plus 5. And we're going to solve. And yes, I didn't realize this until I just looked at the problem. It's the same as the homework. Okay, I'm going to bring this over here. 2y minus 5 equals 5. So 2y is going to equal 10, therefore y is equal to 5. Okay, so I'm going to put that over here, back next to the answer. And then it asks me to solve for z, so I'm going to look at the other diagonal that involves my z's. What equation would I set up for this one? 2z plus 7, equals z plus 9. So subtract my z over. It gives me z plus 7 equals 9. I'm going to subtract my 7 over. And z is equal to 2. So far, so good. All right. Now, let's start with the first piece it's asking me for. It's asking me to find JL. That is the length of this entire segment. So what variable does that involve? What variable's on that segment? The y. 3y minus 5 and y plus 5, right? Okay. So to figure out what it is, I've got to plug that in. So I'm going to start here. 5 plus 5, what is that? 10. And to save myself some work, if that bottom half of the diagonal is 10, what is the top half also going to be? 10, even though I don't really have to plug it in. Okay. And then so together, 10 plus 10 is going to give me a length of 20. Is everybody okay with that part? All right, let's do the other side. We are looking for MK, which is the other diagonal now. So I need to take my number and plug it in. So instead of z, I'm going to put 2. What is 2 plus 9? 11. And if this bottom half is 11, the top part is also 11. So that tells me that MK is going to equal 22. Okay, so just a matter of plugging it in. You could take the numbers and plug them into both sides and do it that way. However, why do twice the work when you know that they're going to be the same, right? Find one of them, the other one's going to be exactly the same. So far, so good. All right, we're going to do this next question in pieces. I want you to first solve for z. Okay, look at your picture and solve for z. We'll come back to x in just a second. I want you to solve for z. That's in my picture. Remember, the diagonals bisect each other. So that 3z minus 4 is the distance from A to E. And the E to C is z plus 5. We're finding a z right now. They're right here. All right, how do I solve for z? What's my equation? Okay, 3z minus 4 is equal to z plus 5. And I'm going to take my smaller z over to my larger one. That's going to give me 2z minus 4 equals 5. I'm going to add my 4. Bring that over here. So that gives me 2z equals 9. That doesn't go in evenly, does it? So let's leave it as a decimal. What is 9 divided by 2? 4.5. Okay. So far, so good. Now, the other part is to find x. And if you look at our picture, we don't really have anything with an x. But in my directions, it does give me some measures. It tells me the measure of angle ADC is 4x. So what I need to do is look at that angle. ADC is this big angle here, and it tells me that that whole thing is 4x. Then the other piece it tells me is the measure of angle DAB is 2x minus 6. So I'm going to look at that one. Let me label that DAB. So that is going to be this angle, if my pen would write, is 2x minus 6. Come on. So here's my question. We know in parallelograms, opposite angles are congruent and consecutive angles are, what did we call those? Supplementary. So are those two angles that we have in that picture, are they across from each other or right next to each other? They're next to each other, right? Which means they are going to be supplementary. So I'm going to take each one of those angles. I'm going to take the 4x plus the other angle, 2x minus 6. And I'm going to set that equal to what if they're supplementary? 180. Okay. So finish that equation. Solve that for x. We had to look at the angles, decide whether they are equal or supplementary based on their placement. And then set up an equation from there. Quick question. Are those x's on the same side of my equation or opposite sides? Same side. So that means we're just going to combine them as they are. What's 4x plus 2x? Okay. And then I'm going to add my 6 over.
Are you adding them?
Yeah, because they're on the same side. If they're on opposite sides, that's when you do the opposite. But if they're on the same side of the equation, you just combine them as they are.
I did it the other way.
What does that give me? 192? And then we divide by 6. And I don't have a calculator. What's 192 divided by 6?
I got you.
How much?
I got you.
31. Thank you. Everybody okay with that?
Yes, ma'am.
Okay, so again, we're keeping in mind the properties of a parallelogram. Opposite angles are congruent, consecutive angles are supplementary, opposite sides are parallel and congruent, and the diagonals bisect each other. That's the information we're using to solve all these problems.
Good question.
Yeah, that's why. Yeah.
I added 180. Oh, I see what I did. Yeah.
So you did, you messed it up?
I did. I made a mistake.
You wasn't tripping, bro.
I'm not tripping. Hey, I'm human and I make mistakes too. I was ahead of myself. Nobody ever said I was perfect. There. Is that better?
Let me do the math now.
It's still 31. I just wrote the wrong number up there.
Oh. Sure?
Yes. Divide it out. Do 186 divided by 6. We good? Okay. My bad. I made a mistake. I'm sorry.
So when it's on the same line, all you gotta do is just add it across.
Yes, if it's on the same side of the equal sign, you just
But
put
if
them
it's
together.
like this,
If they're on opposite sides, then
that's when
you
you
do
do
the
it.
opposite. Yes.
you got to.
Okay, so now we're switching from parallelograms for a minute to talk about proportionality in with lines. So it says if 3 or more parallel lines intersect 2 transversals, okay, we've talked about all these before, parallel lines, transversals, then they cut the transversals proportionally.
That's even.
Kind of. Hold on. Can't get my pen to write. Proportionally. So if you look at my picture, what 3 lines are marked parallel? What's the top line called? Top line. What 2 letters are on that top line? AB. So if AB, line AB, is parallel to, what's that middle line going to be called? CD? Okay. And is also parallel to, what's that bottom line called?
I can't really see through it. That's an AB.
Yeah.
It's the one under CE. Oh.
AB's at the top, CD's in the middle, EF is at the bottom. Okay, so if those 3 lines are parallel, then it's going to cut these transversals proportionally. Does everybody know what a proportion is? One fraction equal to another fraction. Okay? So I want to take a look at the top part. What is that segment called that I just highlighted in yellow? AC. Okay, so we're going to write it like this. Over what segment's below that?
CE.
Uh-huh.
Okay.
So the length of AC over the length of CE, that's one fraction,
It's equal DF.
is equal. Okay, now look, we did AC first, right? AC is at the top. So what segment is at the top of the other side?
BD.
BD, so that goes on the top of my fraction. Ah. And then what's the bottom one? DF.
That's all you do?
Yep.
That's easy.
Yep. Now, the proportions can be done a few different ways as long as you stick to the same position. And what I mean by that is I could have done CE over AC. I could have done bottom over top. I would have just had to do DF over BD, bottom over top. So if I do top over bottom, I need to do top over bottom on the other side. If I do bottom over top, I need to do bottom over top. If my picture happens to be turned sideways, I can do left over right or right over left. I just have to be consistent in either side. Is everybody ready?
Yeah.
All right, let's take a look at our first example. You have calculators, you're going to need them. Are my lines marked parallel in that picture?
Oh, yeah.
Do you see the arrows in the middle?
Yeah, it is. It is.
These 3 right here. You see those arrows? That means those lines are parallel. So this is what we want to do. Starting on the left side, what piece is at the top of the left? All right. Over the bottom part on that same side is 18. Okay. Equals. What's the top number on the other side?
52.
Over the bottom number is X.
Okay.
Now, you may have not done proportions in a while. Anybody remember how to solve a proportion?
No.
Cross multiply. Okay. It doesn't matter which one we start with. I usually start with the diagonal that has an X. I want to multiply these 2. Huh. What's 45 times X?
45.
45X. Okay. Then we put an equal sign. And then we multiply the other diagonal.
18.
18 times 52. 536? 936.
536.
Oh, no.
I said it first.
Okay. How do I finish solving this for my X?
Division. Hold on, let me do it.
Do it.
Get out.
Hold on, no one shout out the answer. Raise your hand. Raise your hand. 30. 20.
20.8.
I got 8.
Is that what you got?
I got 20.8.
Okay. Just making sure. I don't have a calculator. Does that make a little bit of sense?
I did all that stuff. Oh, God.
All right, try 2. Set it up and solve it yourself.
I get what you're saying.
Like, do they do like the little to big, or do they just like?
You can do it however you want. You could do 12 over 30 or 30 over 12. Just as long as you do it the same on the other side.
Hey, I got the answer, Miss Bridget. Come back here. I got the answer. Come back here. Come back here. Come look at me. Boom. You even look at this. Show the work. Show the work. Now you want me to show my work, and when I show my work, you want to look at my work. Look at my work.
Oh, man.
Look at my work. And,
Yes.
and then boom, and then okay, and then what? Yeah, and then off. And, yeah, easy for you. Oh, you know, go. And, see, I can help the class now, and I know what I'm doing.
All of this stuff, well, I do, but
You need to do it the same. So this needs to be first.
I can, but.
All right, set it up for me. What's my proportion? Okay. Okay, hold on just a second. Hold on. Shh. If I do 30 over 12, okay, where is 30 in my picture? Is it?
On the bottom.
It's on the bottom. So I have to do that first, which means when I do the other side, I have to do the bottom part first as well, the one that's directly across from that. Look, hold on. I'm going to show you something. So it should be x over 14, right? Or some of you, a lot of you did 12 over 30 equals what? 14 over x. Let's watch. Let's watch. I like to do the diagonal with the x in it first. 12 times x is just 12x. Okay. Then the diagonal without it. 30 times 14 is 420. Do you notice when I do the other diagonal, I'm getting the same, getting the same two things when I multiply? 12 times x is 12x. And then 30 times 14 is 420. So you can do them either way, as long as you're consistent. If I use the top one over the bottom one, I got to do top over bottom. Bottom over top, bottom over top. We just have to do it the same way. And either way, we divide by 12, and we're going to get x equals
35.
35, yes.
On my daddy. Can we get our phones now, Bridget?
Kingsley, can you let me finish what I'm doing first before I just keep them all period? Okay. Anybody have any questions?